Newton's second law of motion. Now in this video I'm going to explain Newton's second law of motion, but I'm going to explain it from scratch. Understanding Newton's second law of motion requires us to be able to understand or to know what exactly momentum is. Now of course, by definition, momentum is the product of mass and velocity. But what exactly does this mean? This is a mathematical statement that moment is the product of mass and velocity. Let's use an illustration. I'm going to use these two. I'm going to illustrate, this is a voltmeter of course, and this is a cover of a cell holder, but I'm going to take this to be like a big lorry, and this is a small car. These two are moving together. We have the bigger lorry and the smaller lorry, and they are both moving. Of course, because this is a lorry, it is having more mass. It is bigger and it is heavier than this small car. When these two are moving, it is easier to stop this one. Because it has little mass, it is lighter. It's easier to stop this car than this lorry. When this thing is in motion, it is harder to stop it. It takes a lot to get it to stop. The mere fact that this thing is heavy and it is very hard, it is harder to stop it than this light one. In layman's understanding, we shall say that it is harder to stop this thing from being, it is harder to stop this moving lorry. Why? Because it is having more momentum than that one. The reason as to why this lorry is having more momentum than this one is because as this thing is moving, it is heavier. So it is moving with more weight than this, and so it becomes harder to stop it because it is having more momentum as it's moving. It has more momentum than that. Think of momentum as mass in motion. Yeah, momentum is actually mass in motion, because if this mass is like 1,000 kilograms and this mass here is 2 kilograms, this mass in motion is 1,000. It's more than this mass. So because this mass is more than that, this mass here is definitely more momentum than that. Momentum, as a terminology, is affected by two factors. The first factor is that momentum is affected by the mass of the object and then the velocity of the object. Those two affect the momentum of the object. That is why we shall say that by definition, momentum is the product of mass and velocity. Mathematically speaking, momentum is equal to mass times velocity, and momentum is denoted by small p. P is going to be m, mass, and velocity, just like that. Now we all know that mass, the SI unit for mass is kilograms, and the SI unit for velocity is meters per second to the power -1. It's meters per second. So it means that the SI unit for momentum is kilogram meters per second. This is the SI unit for momentum. Now that this is the mathematical representation of momentum and its SI unit, now let's look at let's consider a body that has been moving from a certain velocity, and it's moving and its velocity is increasing. Right before us is a velocity time graph. We are having this graph here. It is, let's say we are having one of those cars that we've been illustrating using our illustration before. It is right here, the car, and it is moving. Let's say as it started moving, it started at a certain initial velocity. Let's call the initial velocity u. So as time goes by, this car's velocity keeps increasing. So as it's moving, let's say after 1 second, its velocity increases to a new velocity. As it's moving to maybe the second velocity, the second, its velocity keeps increasing to a new velocity. So this car, as it is moving, its velocity keeps increasing from a certain velocity u to a certain velocity v. Now remember, we said that momentum, which is denoted by p, is going to be equal to mass times velocity. Now if we are looking at a specific car, it means that as this car is moving, its mass will be constant, right? Yes, its mass will keep constant. It won't change. But it is its velocity that is increasing from this initial velocity up to a certain final velocity we shall call v. So it means even as the car is moving, it moves, its momentum keeps changing depending on the velocity of that car. or the velocity of that body that is moving. So it means that if it moves at a higher speed, it means its momentum will be high. And if the velocity is low, or if it's moving at a lower speed, its velocity will be low. So what does this mean? This simply means that as this velocity keeps changing, whether the velocity is very high or very low, it is changing with respect to time. This velocity can move from here, it can change instantaneously up to velocity v, and it will take a shorter time here. Likewise, this velocity can move from here up to there, and it will, in both cases here and here, the velocity, the final velocity has been arrived at, but in different time frames. This has taken a shorter time than that one to reach this final velocity. So this simply means that even as a body is moving, its rate of change of momentum, or if its rate of change of velocity, or the rate at which this momentum keeps changing depending on this velocity, will also vary. Now, according to Newton, he observed in his experiments that this rate of change of momentum as the body is moving is directly proportional to the force applied, or to the force that is making this body move. And that rate of change of momentum being directly proportional to the force that is applied is what is constituting, or it is what is making Newton's second law of motion. So if I may restate it, Newton's second law of motion simply states that the rate of change of momentum of a body is directly proportional to the force applied, and it takes place in the direction of the force. So we say that the rate of change of momentum is directly proportional to the force applied. Let's take this point and that point. Right here, when the body, we are taking a car, it's having a certain mass m. This point, it is having an initial velocity which we are going to call u. So it means to get the initial momentum of this car, it's going to be mass times initial velocity. Let's call this p initial. The initial momentum is mu. Then it means that the final momentum, after this body has moved at this point when the velocity has now changed to v, it means the final momentum, that is momentum final, is going to be equal to mass of the body or the car times v, the final velocity. Now, that being said, what is the change in momentum as the body moves from this point to that point? Now, change in momentum, it's final momentum minus initial momentum. So our final momentum, we denoted it as pf minus initial momentum, which is pi. So our final momentum in this case, it is mass times the final velocity, so it's going to be mv minus initial momentum, which is m times u. So this here is our change in momentum. Let me call it change. Delta means change in momentum. Now, what about Newton's law talks about the rate of change of momentum. So it means when we are dealing with the rate of change of this, we are going to include the time element, because now the thing was moving from this point to move from an initial velocity of u to a final velocity of v. There was a certain time that was covered, a certain change in time. So to find the rate of change of this momentum, so the rate of change of momentum is going to be given by our final momentum, which is mass times final velocity, minus initial momentum, which is mass times initial velocity. Divide that by the change in time. Let's call it delta t, change in time, or simply t. So this rate of change of momentum, which is this, is what Newton is saying is directly proportional to the force applied. So it means that this expression is directly proportional to the force applied. So according to Newton's second law of motion, he says that the rate of change of momentum is directly proportional to the force applied. And in this case, the rate of change of momentum here is this, mv minus mu. Divide that by the change in time is directly proportional to the force applied. Now, if we are to factorize out the m, the mass, m is outside into v minus u over the change in time. That is directly proportional to the force applied. Now if we may look at this, this is v minus u over time. When we factorize out the m, this becomes the rate of change of velocity, that is final velocity minus initial velocity divided by time. And from our previous videos, we concluded that the rate of change of velocity is actually acceleration, or actually by definition, we know acceleration to be the rate of change of velocity, because it's velocity, change in velocity over change in time. So the rate of change of velocity is actually acceleration. So you will find that this expression actually is mass times acceleration is directly proportional to F. Or if I may rearrange this, it means force is directly proportional to ma. Now, to remove this constant of proportionality, of course, we shall introduce a constant. F is going to be equal to k ma, where m is mass, a is acceleration, then k is the constant. Now, to eliminate that constant, k, if the mass that is moving is 1 kilogram, and it is moving at an acceleration of 1 meter per second, and the force being applied is 1 Newton, it means our value of k will be equal to 1. And since our value of k will be equal to 1 under those conditions, it therefore makes us conclude that F is going to be equal to k, which is 1, which is m times a. So F is equal to ma is an equation that is also used to define Newton's second law of motion. Now force here is in newtons, or let's say the SI unit of force is in newtons. And what is a newton? If I may derive it, it is that F being equal to mass times acceleration, we know that mass is in kilograms, and then the acceleration is in times meters per second squared. So it means that the force is equal to kilogram meters per second squared. So it means that 1 Newton is equivalent to 1 kilograms meters per second squared. So if we may define what a Newton is, by definition, a Newton is a force which produces an acceleration of 1 meters per second when it acts on a body whose mass is 1 kilogram. And so this is how we can also define the Newton. And also Newton's second law of motion is expressed mathematically like this. Again, this also leads us to another phenomena. If we may start from where we started here, that change in momentum is directly proportional to the force, and probably you just introduced the equal signs that F is equal to mv minus mu, divide that by the change in momentum, you will find that if we multiply this time on both sides, times change in time here and times change in time right there, we shall end up with an expression that force times the change in time is equal to mv minus mu. Now mv minus mu is simply the change in momentum. So this change in momentum is equal to force times time, or force times the change in time. Now this force times the change in time is what we are calling impulse. And this impulse is equal to, and the change in momentum of a body is going to be dependent on the force and the time. So by definition, we can say that the impulse is a term that quantifies the overall effect of a force acting over time. And of course, impulse is conventionally given the symbol J. This impulse is given a symbol J. So J, which is the impulse, is going to be equal to change in momentum, which is mv minus mu. If we are to make m outside the brackets, m into v minus u. M, the SI unit for mass, is kilograms. And the SI unit for velocity, this is velocity, initial velocity minus final velocity. So whatever answer we are getting here is velocity, and it is in meters per second square, second to the power 1, meters per second. Now the SI unit for impulse is kilogram meters per second to the. Now sometimes the SI unit for impulse is regarded to as Newton seconds. Now how does this Newton second come in? Of course, if we break this down, it will lead us to this. This is the same as saying, we know that 1 Newton, from what we've been doing previously, force is equal to MA. We established that 1 Newton is the same as 1 kilogram meters per second squared. So this is like saying kilogram meters per second to the power negative 2. That is the Newton we have put here. Multiply that by the second. So this is the same as saying kilogram meters per second, kilogram meters, divide that by second squared, because this is s to the power negative 2. So s squared, multiply that by s. When you cancel that s with one of that, you remain with kilogram meters over second, which is the same as saying kilogram meters per second, which is the same as our earlier conclusion. So it is preferable to say that the SI unit for impulse is Newton seconds. So if I may make a recap, in this video we have covered about Newton's second law of motion. We started with momentum, which we said that was the product of mass and velocity. We went ahead and talked about the Newton's second law of motion, which states that the rate of change of momentum of a body is directly proportional to the force applied, and it takes place in the direction of the force. We went ahead and talked about the impulse, which by definition, we said that it is a term that quantifies the overall effect of a force acting over time. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.